Hello everyone, welcome to my new programming club. Today we will be solving another daily Leetcode challenge, and the challenge name is Reconstruct Itinerary. So you are given a list of airline tickets where ticket represents a departure airport and arrival airport in the form of from and to. So this from will represent the departure airport and to represent the arrival airport. You have to reconstruct the itinerary in order and return it. All of the tickets belong to a man who start from JFK, so you will always start from this particular location of airport. Thus, the itinerary must begin with JFK. If there are multiple valid itineraries, you should return the itinerary which has the smallest lexical order when the string is read as a single string. So what it means is, uh, let's say you started from A, B, this is the itinerary, let's say, then it should be the lexicographically smallest if several such itineraries are possible. Let's say it was another possibility. Now among these two, the lexicographically smallest will be this one. So you will answer this one. This is what you are required to answer. So let's have a look at the constraints. So the number of tickets will be of order 300, and the tickets lengths, each element length will be of 2, which will include from and to arrival and departure and arrival airports. And from and to will consist of only English uppercase, consist of uppercase English letters, and from will not be equal to 2. So at first, you might think that you can apply a simple DFS here, which is a depth first search. Those of you who are not familiar with what depth first search is, uh, it is a searching technique in which you explore the very end of your branch while searching for something, and then you browse back and explore another possibility. Then once you fully explore it, then you explore another. So it is basically you explore one possibility till the very end, and when you are done with it, you will come back and explore another possibility. So this is a depth first search. It is a searching technique. Those of you who are not familiar with I will be providing a link for depth first search. Uh, Here, two things are mentioned. That first of all, if there are multiple uh, itinerary is valid, then you have to return the lexicographically smallest one. And one is that you should use a thing. You must use all the tickets once and only once. So all the tickets should be used only once. Now, we will take care of this while doing the depth first search, but to take care of this part, we will use a data structure called priority queue. Or say, let me quickly change the slide. Priority queue or min heap. Basically, it will store the smallest string on top. So what we will do is we will construct a graph of uh, departure airport, and all the airports from this that are accessible from this particular airport. So all of its destinations, you can say, or all of its neighbors. All of the airports reachable from current airport, or say departure airport. And we will use priority queues to store these airports. And so whenever you will inquiry for the next airport that we can go to, you will always get the smallest, lexicographically smallest one. This is to get lexicographically or alphabetically smallest one. Smallest airport name. So, and when you will get the next airport, when you will get next airport to go to, or your arrival airport, you will remove the connection between arrival and departure airport. Basically, you will tear your door of your ticket, or you will throw away your ticket once used. So that's what you will be doing. So let's have a look at the example. Let's take this example. starting from JFK, as it's mentioned that the man who is having these tickets always departs from JFK. So first you will be constructing the graph. So you will see what are the neighbors of JFK, and you will maintain a increasing order lexicographically. So JFK is having two neighbors, ATL and SFO. ATL will come first, then SFO. Now for ATL, you are having two neighbors. They are JFK and SFO. So JFK is lexicographically smaller. So it will come first and then SFO. And for SFO, you are only having one neighbor or one arrival airport that you can arrive if you depart from SFO airport, which is ATL. Now, once you start from JFK, then you are having two choices, ATL and SFO. Since you will be using a priority queue, the priority queue will always give you the smaller one, which is let me quickly change the color, which is ATL here. So you will get ATL. Now once you are at ATL, you will see what's the what is in the top of the priority queue at ATL in the graph. So it's JFK. So you will be again going to JFK. Now you have arrived at JFK. Now you will be coming back. Also from JFK, there is another. So this will be deleted. So SFO is left only. So you will visit SFO. Now from SFO, it will be removed. So you will arrive at this ATL, SFO. Then SFO is having only ATL. So you will be at ATL. So this will be your order. As you can see, JFK, ATL, JFK, then SFO, then again ATL, and ATL was having one remaining, so you will add SFO. So this will be the correct order. So JFK, ATL, JFK, then SFO, then ATL, and then SFO. So this will be your approach. So this particular one will be stored in a priority queue. Or min heap. Those of you who are new to this data structure, I will be providing a link for article describing this data structure. Basically, it will, if you have implemented a min heap, then lexicographically smallest string will be present at the top of your heap. So that's pretty much it. Now, since you are removing airports as you are visiting them, so there will not be a chance that you will be using a ticket and you will be using all the tickets. So that's pretty much it for the approach. Now let's have a quick look at the implementation. So this is the implementation. Here, first of all, you will construct a graph. with key as the departure airport and values as the possible arrival airports. So then once you have formed the graph, then you will use this uh, list or say array to store lexicographically smallest itinerary possible. You may ask how you will be able to store the smallest one, because we are using priority queue to store the possible arrival airports. So each time priority queue will provide you the smallest, lexicographically smallest arrival airport possible. So this is nothing but a standard DFS. That first search for building the itinerary. So as you are using the tickets, them away so that they can't be used. So you will keep emptying your priority queue of possible arrival airports from a current departure airport. You will keep emptying or say keep removing the possible arrival airports from current departure airport, which is nothing but source. And you will always get the lexicographically smallest arrival airport. And that's pretty much it. Then you at last, once you are done with visiting all the arrival airports, once you are done with recursion, for the current branch, then you will add the airport to itinerary. So that's pretty much it for the solution part. If you are still having any doubts, please feel free to ask them in the comment section. I will be more than happy to answer them. The code will be available in C++ and Java both. So thank you for watching. Thanks.